We have a uniform motion problem here. Esteban's motorboat took 3 hours. So 3 hours, that's going to be a time to make a trip downstream with a 6 mile per hour current. So if we're going downstream, the current is working with us. So it's going to be adding to our speed. The return trip against the same current took 5 hours. So here's the other time. And if we're going against the current, then that means that the current is working against us and it's going to make us travel at a slower rate. Find the speed of Esteban's boat in still water. And what they mean by that is without current. How fast is he trying to go? So it looks like we're going to be going downstream and then we're going to be coming back upstream. So that's how I'm going to label my rows, downstream and upstream. And then I'm going to have a distance that I'm going to travel, a rate, and a time. And then I'm going to start to fill in my columns. Well, it's saying right here to go downstream it took Esteban 3 hours. So I'm going to put that under my T column. And it says that he had a 6 mile per hour current. So it doesn't tell us how fast he's going because that's actually what we're looking for. So his current is going to be added to his rate. So the current is 6 miles per hour. I'm going to add 6 miles per hour to the rate that he's going. Then on the return trip against the same current, it took 5 hours. So that means that I have a 5 here. And we're going against the current now, so the rate that Esteban is going to be decreased by 6 miles per hour. And then the distance they traveled, well, the distance we don't know, but he went downstream and then he came back upstream following the same route. So that's going to be our D. So then to figure out what D is for each one of these trips, I'm going to take D is equal to RT. So for downstream, it's going to be equal to 3 times R plus 6, which is equal to 3R plus 18, and that is downstream. D for upstream, again, RT, is going to be equal to 5 times R minus 6. Using your distributive property, 5R minus 30, and that's upstream. Well, since we know that their distances are going to be the same, then we can take their distance, their expressions for their distance, and set them equally to each other. So then we're going to have 3R plus 18 equals 5R minus 30. And we're going to solve the problem for R. And remember, R is the speed Esteban's boat is going in still water. So I'm going to subtract 3R from both sides, and I get 2R minus 30. And then I'm going to add 30 to both sides. And I end up with 48 equals 2R. Dividing by 2, I end up with R equals 24. So the speed of Esteban's boat in still water is 24 miles per hour.